In this video, we'll discuss factoring. Now, factoring is a component of the distributive property. Often we think about the distributive property as taking a term outside an expression and distributing it to each of the parts inside. So in this case, that would be A times B plus or minus A times C. But the distributive property also allows us to go the opposite direction, which is to factor out a term from everything and rewrite it in this parentheses form. So when we think about the factoring, we're going to be thinking about the reverse of the distributive property. And we're going to be looking to factor out some common term or even an expression and then have remaining components from that initial expression. So if I think about going the reverse direction, I would say, well, what can I pull out of both terms or factor from both of these terms? I can factor an A. So that puts an A outside my parentheses and the B plus C remaining inside because I divide both terms by that A. So the first type of factoring we'll talk about is called monomial factoring. Here we factor out a single common term from everything in the algebraic expression. What is left then after factoring out that term is all the remaining components to that expression. So let's look at an expression here. 6r to the fourth s to the third t plus 10r to the fifth s squared t to the fourth. So here we have an expanded expression and we want to factor it. That means we're going to look first at the coefficients, then each of the variables and say, can we factor out anything from each of those? In this case, when I look at 6 and 10, they are both divisible by 2. So my common coefficient is 2. I'll divide both terms by 2. When I look at my r's, I have r to the fourth and r to the fifth. They both have a maximum of r to the fourth. So I'm going to divide that out of both of those terms. With my s's, I have s cubed and s squared. So I'm going to factor out s squared because that's the most I can pull from both. And then I have a t to the first and a t to the fourth. So the greatest I can pull out is t to the first. So this becomes my monomial in front of the expression. And then what I'm doing technically is dividing each term by that monomial, and that's what's remaining inside the expression. So 6 divided by 2 is 3. R to the fourth divided by r to the fourth becomes 1. They simplify. S cubed divided by s squared is s, and then t divided by t becomes 1. It simplifies out. I do the same thing then with 10, and 10 divided by 2 is 5. R to the fifth divided by r to the fourth is r. S squared divided by s squared simplifies out, and then t to the fourth divided by t is t to the third. So I can think about it as I'm going to divide each of those terms in the expression by what I factored. Now, the next type of factoring we'll talk about is called group factoring. This is when we have 4 terms in our expression. And what we're trying to do here is actually see, can we come up with a common factor from each of those expressions? Now I'm going to give you a first step that I recommend that becomes very helpful in maintaining positives and negatives. Whenever I see a minus, I go through and say, let's change that to plus a negative. So the sum of the negative term. So here, those would become 6x squared plus 3x plus a negative 8xy to the fourth plus a negative 4y to the fourth. It becomes a little bit easier to keep track of what's going on after this. So my second step then is to group the first 2 terms together and then group the last 2 terms together. And by doing so, I'm able to leave that plus in between the 3x and the negative 8xy to the fourth. That's why it's very helpful to change this to plus and negative when needed. So here's my grouping then. So I group 6x squared plus 3x, and then I group negative 8xy to the fourth plus negative 4y to the fourth. My third step then is to do monomial factoring on each of these groups individually. So when I look at 6x squared plus 3x, I'm saying, what's the most I can group factor? Both of those terms are divisible by 3x. So 6x squared divided by 3x would remain of 2x, and then 3x divided by 3x gives me positive 1. That's the key to remember here. This is when I'm factoring, I'm dividing out a term. I'm not subtracting it, I'm dividing it. So 3x divided by 3x is 1. I have to have that 1. When I look at my next grouping, what I can factor out of both of these is a negative 4y. So I keep the plus, and I'm going to put the negative 4y to the fourth. Negative 8xy to the fourth divided by negative 4y to the fourth is 2x. And then negative 4y to the fourth divided by negative 4y to the fourth is positive 1. And this is very important because as I do this, I want that common expression between the two to be identical. If not, I don't have a factorable solution, and I need to see is it because of my negatives or because I can't factor this grouping. Once I have it though, I'm looking and saying I have that positive grouping here that is identical. I will say that my factoring is one, the common expression, and the other is the two factors that were factored out. So this would become negative or positive 3x minus 4y to the fourth. That's my first grouping. The other is the common grouping, 2x plus 1. And it doesn't matter which of those two groupings you put first. It'll give you the same thing because it's multiplication. The other thing you'll notice is that I did change this back from plus and negative to minus, and that's because common way of writing these problems when we get them factored is to put the minus there. Now, let's look at the idea of factoring a trinomial. So the other grouping had 4 factors, this has 3. So our first step really is to find a way to take that middle term and split it into 2 factors so we can follow our rules of group factoring. To do that, the first thing I'm going to do is find the product of my first term and my constant. So we want to make sure they're in order by degree. So my first term is 1. In this case, in my last term, my constant is negative 12. Well, 1 times negative 12 is negative 12. That's step 1. Step 2 is I'm going to then look at find sums for the factors of that product and find one that will match exactly my middle term because I want to write an equivalent statement so that if I simplified it, I'd be back to x squared plus x minus 12. So let's go through factors of negative 12. I could do negative 1 times 12, but when I add those two numbers together, that adds to 11, not positive 1, so that's not what I want. I could have tried negative 2 times 6, but negative 2 plus 6 is 4. I need positive 1. I'll try it one more time. I've got negative 3 times 4. Negative 3 plus 4 is positive 1. That's the one I need. So what I do then, once I have my 2 factors, is I'm going to replace my middle term with those factors. Again, we're going from 3 factors or 3 terms in our trinomial, trying to make it 4 terms so we can do group factoring. So I'll replace the middle term, and now I have x squared plus negative 3x plus 4x plus negative 12. Again, I do this so that I have the pluses and then minus sign gets attached as that negative. It makes it much easier to do my grouping. Now that I have 4 terms, I can group factor. So I group my first 2 terms and then I group my last 2 terms. When I look at this first grouping, both of those I can factor out an x, and that's it. So that would give me x plus negative 3. On my second 2 terms, they're both divisible by 4, which again leaves me with x plus negative 3. And this is where having the negative attached as that plus and negative becomes very helpful to pay attention to whether I need to pull out a negative factor or a positive factor. Now I'll look and say I have a common grouping, which is exactly what I want. So I know that I can make my first one be the 2 factors and my second one be the common grouping. X plus 4, x minus 3. Now let's look at another example, this time where I do have a coefficient on my x squared. Just remember though, I'm not looking for the product of negative 5, I'm looking for the product of negative 5 times 8. It's the first term, the highest degree, times my constant. So that's a product of negative 40. Then I'm looking for those factors to see what I can add to negative 18. So let's go through our factors of negative 40 and their sums. Well, I've got 1 times negative 40, that's negative 39. That's too big. I could do 2 times negative 20. Well, 2 plus negative 20 is negative 18. That's exactly what I want. So what that tells me is I'm going to replace my middle term with these two factors so that I can group factor. So that means I'll have 8x squared plus 2x plus negative 20x plus negative 5. It doesn't matter which order you put these in, just again, use the plus and negative because it will make it a lot easier to do your group factoring. So when I group my 2 and then I group my second 2, I can then look and say, well, I can pull out a 2x and that will leave me with 4x plus 1. I can pull out a negative 5. And I want to do that because I can see these terms that are common are positive over here. So I'll pull out the negative 5 because negative 20 divided by negative 5 is positive 4x. Negative 5 divided by negative 5 is positive 1. So that now my common grouping is identical. So it helps to be able to look and say about those plus and minuses and those negatives to figure out how I need to do my grouping. Now that I have a common grouping, I can say one grouping is my two factors. My other grouping is the common. So 2x minus 5, 4x plus 1. Now, we have other considerations that we could look at. One of those is called the difference of perfect squares. And the key there is difference. They have to be minus. So if I have a perfect square subtracting another perfect square, every time, I don't have to go through the whole process of creating the trinomial and then group factoring. I can recognize that it will follow this pattern. It will be the square root of a plus b times the square root of a minus b. So there, I just need to know what are my perfect squares and what's their square root. So let's look at an example. If I have factor 9x squared minus 49, it's only two terms. I could put the plus 0x there and then do a trinomial, or I could recognize it's a difference of perfect squares. The square root of 9x squared is 3x. The square root of 49 is 7. That means that if I follow my process here, that's 3x minus 7 and 3x plus 7. Much, much easier as long as I can identify. And this only works if it's subtraction. It must be the difference. All right, so let's put this all together and look at another example. Here we have a polynomial that's greater than 2. So we have x to the 5th. We're like, whoa, that's way different than what we did before. But we still look and see, let's start with monomials. Let's look and say, can we do a trinomial based on what's left? And can we even use difference of perfect squares? We're looking for all those parts of the factoring to help us make it something we can work with. So the first thing I look at this and say is, well, I have a common term I can factor out of both of those. I can divide them both, or I can factor out an x from both terms. That will leave me with x times the quantity x to the 4th minus 256. Now I'll say, okay, that's a difference. Are each of those perfect squares? Well, I can take the square root of x to the 4th, that's x squared. I can take the square root of 256, and that's 16. I can use my calculator to double check myself there. So since it's a difference of perfect squares, I'm going to use those parts, the x squared and then the 16. So what I have now is the x from where I factored it originally, and then x squared minus 16 and x squared plus 16, just like I did that difference of perfect squares a minute ago. Now I do one more look and say, okay, x I cannot factor anymore. X squared plus 16, that's a sum, not a difference, so I have to leave that one alone. There's nothing I can do to that one. But here is a difference, and I say, are they both perfect squares? X squared, yes. 16, yes. Square root of 16 is 4. So I can factor this middle one again, since it's a perfect square. So this would become x times the quantity x minus 4 times the quantity x plus 4 times the quantity x squared plus 16. Now, factored fully, factored fully, factored fully, and nothing else I can do to that final term.